This is assignment number 8. Assignment number 7 was the first part of our assignment on chaos. This is the second part. In the first assignment, we studied the idea that this iteration, x squared plus c, for a fixed value of c, it has certain long-term behavior. And what we saw was that depending on what region of the parameter c we're in, we got different types of long-term behavior, long-term values. So we saw that in the first interval, we got a single long-term value, that there was a trend towards a single value. In the next interval, when c was a bit more negative, we saw that there were 2 long-term values. And then later on, it was 4 long-term values, and then after a while, it just became chaotic, and there wasn't any pattern in the long-term values. So this assignment, in assignment number 8, what we're trying to do is get a general picture of the long-term values. So for example, what we want to know is that for a given value of c, like we know that for certain values of c, right, there's going to be a single long-term value somewhere, right? And we know that in a certain range of c, there will always be a single long-term value. So here what I'm plotting is the long-term values versus c. But we also know that in some other range, somewhere over here, there were more than one long-term value for the iteration. So there was something like this, that there were 2 different long-term values. And then even more negative, we got a whole bunch of long-term values for c. So what I'm interested, and then for certain other value ranges of c, we got some kind of chaos here. We don't really know what's going on. So what I'm interested in is to accurately produce a graph like this, which shows you all of the long-term values, or at least approximations of the long-term values, as a function of c. So in the range from, let's say, minus 2 to plus 0.5 or whatever, minus 2 to minus 0.5. Okay, now, so you can open up your worksheet that you were using to do the first part of the assignment, to do assignment 7, and you can continue using that code to do your computations. And what I'm going to do here is I'm just going to give you a few pointers on how you might use the software to make this graph. But you already know how to produce long-term values, and so in a way you already know how to produce this graph. I'm just going to show you maybe easier ways that you could do it. And so to do that, I just want to review a couple of basic things. So when you use a worksheet in Sage, this worksheet is really what you're allowed to do here is you can put in Python commands. Python is a very popular programming language. So that's why you can always test it out by seeing if you can do arithmetic, shift enter, and you get your answer. Okay, now in Python, you can always make a list. A list is in square brackets, and something like this, 0, 1, 2, 3, that would be a list. Actually, another way of making the same list is to say this, range 5, let's say. Range 5, it produces a list with 5 things in it, starting with 0. So it's 0, 1, 2, 3, 4. And so we can always give a list a name, and you always use the equal sign to give something a name. So let's say I'll call this list range 5. I'll give it the name li for list, short for list. Okay, shift enter. And so after I've defined li, now I have it, and I can ask it questions. So for example, I can say, what is the 0th element on the list? So the numbering always starts with 0, which is a little bit of an annoyance, but anyway, what's the 0th element on the list? And it'll tell me that the answer is 0. What is the 3rd element on the list? That should give me 3. Okay, now your list could be any other thing. So it could be, let's say I make a list. Instead of numbers, I'll use words. So with words, you can put them in quotations. So you can put Marco, John, Emily, right? So this is a list of 3 names, and I'm giving the list a name itself, which is this, names. Okay, and I can also ask the question, same thing, what's the 0th element on the list of names? And it should give Marco. And if I ask for the 2nd element, it's the element, it's the name that is in the place 0, 1, 2. So it should be Emily, according to the way it's numbered here, starting with 0. Okay, so so that's how the lists work. Now there's a kind of clever thing that if you put a -1, then what it does is it doesn't give you the 0th or the 1st or the 2nd. It gives you the -1, which kind of wraps around and gives you the last element. So list li -1 should give you the last element of this list, which is 4. So let's just check to see it gives you that. And it's true. And if I do the same thing with the names list, the -1 element will give me the last name, which should be Emily. So that's, putting a -1 is just an easy way of asking for the last element on the list. You can also, so let's say that I change li now, and I say, make it a list of 200 numbers instead of just 5. Okay. So if I ask for li -1 now, it should give me the last number, which is 199. Okay, and the other thing that I could ask it is something like this. So I could ask for -10 colon nothing. And if I shift enter on that, let's see what it gives. So what this is giving me is it's going from the end of the list, it's going 10 from the end. It's giving me not the last element, it's giving me the 10th element from the end, all the way up to the end. So this means from this to here, and since I haven't put anything, it'll just give it to me until the end. I could put here, let's say -3, and it should give me this one, this one, this one, this one, this one, this one, and this one, and it should cut it off at this point. So let's see what it gives. So yeah, it gives me up to there. So you can use this colon to kind of go from a point to another point. So you can also use the simplest way is to use it in this way. If I ask for 4 to 20, then it should give me the part of the list from the 4th position to the 20th position, and that's what it gives. Okay, so this is just how you use lists in Python. Oh, and I should also say that, let me just delete all this. Okay, so I can also make a list of points. Okay, and so the points would be things like 1, 2, that would be the first point, and then there's 3, 2, 5, 4, 3, 5, 4, okay? So notice that when I entered this list of points, the important thing is that it's a list, so I have the square brackets, and each point, each thing in the list is actually a pair of numbers in round brackets, and that's how you make points like that. So what I've created is a list of points, and then I can graph this by just putting it in, by applying this function point to it. And then it gives me a graph of the points. So sorry, I could have named this anything. I could have said, you know, I could call it anything, cat, right? Shift enter. And then if I wanted to graph that list, which I gave the name cat, then I would say point cat, and it should give me the points on a graph. The graphing function just happens to be called point. And if I want, actually, see these dots here, they're a little bit large. If I want them to be smaller or larger, I can put size equal to 1. That would make them 1 pixel. And that should make them a little smaller. That does make it a little smaller. Okay. So that's just how you make a list of points, and also how you graph the points. Okay. So let me just continue here. Let's remember what our function is. So remember that the function was defined to be so that it returns, what does it return? It returns the square of the input plus c. Okay, now when I'm creating that graph of all of the long-term values, I'm going to be changing the value of c. Let's say from -2 to -0.5, I'm going to want, let's say, 1,000 values of c. And so I need to be able to easily change this function and change the value of c. So what I'm going to do is I'm going to put c into the function itself, fxc, and it's going to return x squared plus c. Okay, so let me shift enter on that. So this means that if I want to know the value of the function at 0 for c equals to minus 0.12, right? Then it'll give me that. And if I wanted to iterate this, I could do like f applied to this, but you have to tell it what c is. So I have to remind it that c is 0.12. And this is going to give me the iteration of f on f with the fixed value of c being minus 0.12, okay? So this is just a way of doing it so that you can easily change the value of c, as we range through the parameter range, the interval. Okay, now, so what we really want is that for every c, we want to define a function that will give us a list of the long-term values. So how do we do that? Well, let me give you an example of something you might do. So I'll define a function which is LTV, and what it does, it takes an input which is c, and it gives back a list of points which should be on the graph, in the sense that each point should be a long-term value for the value c, for the parameter value c. So let me just write that in words here in quotation marks. I'll say that this function returns the last 50. Let's say, just to be safe, I'm gonna record the last 50 iterations. In the iteration, the last 50 points of iterating 500 times, let's say. Okay, so what does that mean? So we're going to be outputting a list of points, and I'll give that the name points. And the list, I want this list to contain, so what do I want to be in this list? So I want to do the iteration for the value of C that I've chosen, this C here. I want to do the iteration 500 times just to be certain that I have good values. And I don't want to graph all 500 values, I just want the long-term values. So I want to give the last 50 points. Okay, so what am I going to do? So first I want to build the iteration. So you already have it in your worksheet how to do the iteration, but I'm going to do it again here. So you start off with the first point, which is 0. Okay, and so this will be a point on the graph for whatever the value of C is. Well, sorry, I won't necessarily want to put this on the graph because it's just the first point in the iteration. This is just the first point in the iteration. Okay, so how do I iterate the function on this? So I want to iterate, let's say 500 times. So what you do is you make a loop of 500 times. So you do it like this: for I in a range of 500. Okay, so this will create it'll make a loop and it'll do something 500 times. So what do I want it to do? Well, I want to create a new point, and I want that new point to be the point C, and then I want to apply the function to the list points. So I want to apply f to what? To the list points, and I want the last element on this list. So I put points minus 1. That gives me the last point on the list. But remember that the points, they have two components. They have C and also the actual value of f. So what I want is, I have to apply f to a value x, and this is actually a pair of values cx. So I need to take the last value in that list. Oh, and I need to tell f what the value of C is, which is just C. Okay, so what I'm saying is that this is going to be the new point. So if I apply this to this old point, then what it's going to do is it's going to look at the value 0. Okay, that is here. This expression here will pick out the value 0, and it'll plug it in here. And so you're going to be computing f of 0, comma C. Okay, and then what do we want to do with this new point? We want to append it to the list. Points append this new point. Okay, so it's going to append those new points 500 times, and it's going to make the list points very, very long. And then what I want to do is return the list points. But I don't want all 500 iterations. I just want the last 50. So I'm going to do from minus 50 to the end. Okay, so that's what long-term values, this function LTV does. It'll iterate the function on 0 500 times, just like we did in assignment 7, and it will return me a bunch of points, 50 of them, which are the long-term values. I mean, normally we don't need that many. You could change this to fewer. Like, obviously, in some ranges, you know that there's only 2 long-term values, so this only has to be 2, or in the case where you have 4 long-term values, you'll only need 4, the last 4. But I just want to be safe, since I don't know which range I'm working in. I'll take all 50 of the last values. Okay. Okay, and so for example, if I so this is going to give us a bunch of points. So for example, let's say that I want a graph of the long-term values for the value minus 0.5. Okay. So we know that this number, minus 0.5, is in a range where there's only a single long-term value. And so this should only give me 1 point in the graph. So let's see what happens. Yeah. So here we get only a single long-term value. Okay. But if we were, oh, actually, so it's graphing 50 points here, but they're all on top of each other since the long-term values are, they're almost all the same. So you only really see 1 point. So if I do, let's say, minus 1.4, then I'm getting a whole bunch of long-term values, you see. So this thing is giving me the points for this value of C. It's giving me the long-term values, okay? But I want the long-term values for a whole bunch of values of C. I want to fill up this whole graph for different values of C. So to do that, I'm going to need to make a list of points for this value of C and add it to a list of points for the next value and add it to a list of the points to the next value. So I need to add a whole bunch of lists together to get a big, huge list of points which will fill up this whole graph. Okay, and for that I just need to kind of put them all together. So I'll say long-term values in an interval from A to B. So this function, oops, I forgot to put a colon here. So this function should return long-term values for, let's say, 1,000 choices of C between A and B. Okay, so between certain, let's say I want to know the long-term values from this value of C to this value of C, from A to B. And so what do I need to do? So I'm going to need a list of points. So let me just make it empty to begin with. And then I'm going to loop and make the list longer and longer. And so what I want to do is I want to add these long-term values that this function gives me. So these points, I want to add them to this list for 1,000 choices of C. So I'm going to loop 1,000 times. So I'll say for I in range 1,000, let's say. You can change this if you want. What do we want to do? Well, we want to extend the list. So there's a function called extend. We want to take the list points and we want to extend it by adding another list to it. And which list do we want? Well, we want to add LTV of C. Okay, so remember that LTV of C is the thing that gives me this list of points. And I want to take that list and stick it onto this list points to make that list longer. And so that'll, okay, but this line here, it produces the long-term values for only one value of C. And what I need to do is I need to range between A and B. So what I'm going to do is I'll say that C is equal to, I'll just write this and then you'll see what I mean. If I say it's C equals A plus I times B minus A divided by 1,000. So what does this mean? This means that this I is going to range from 0 to 1,000 in the loop. So the first time it runs, I will be equal to 0. If I is equal to 0, then this stuff is just all 0, and C begins at A, which is good because I need C to range between A and B. Okay, so when I is equal to 0, this is C is equal to A, and I'm going to add LTV of 0 will be equal to 1. And then what I'm doing is I'm adding 1 over 1,000, 1,000th of the distance from B to A, I'm adding it to A. So I'm moving over 1, right? So okay, and then as I ranges, so if I is equal to 2, 3, 4, 5, then I'm adding 1,000th, each time I'm adding 1,000th of the difference between B and A, and so I'm slowly moving from A to B. And if you think what happens, if I is equal to 1,000, then this part here is just 1,000 times b minus a over 1,000. So it's just b minus a. And if you add that to a, then you get b. So c goes from a to b. Okay. And then once we've made this extremely long list, I want to return this list to the program, and that will do it. Okay, so that defines the function